today we're going to be talking about parallel lines and perpendicular lines. What I'd like you guys to do, I would like you guys to write in your journal, parallel and perpendicular. We're going to write down a couple of symbols that mean parallel and perpendicular, so you don't have to write parallel and perpendicular all the time. So make a little chart, just like this. Alright. Now, the parallel symbol I'm going to do in green so you can see that is actually, it looks like a pair of L's. That's the parallel symbol. The perpendicular symbol looks like this. It looks like an upside down capital T. So whenever you see me write this, that means parallel. Whenever you see me write this, that means perpendicular. Those are two symbols that you don't have to write those two words if I write them down. Okay, as long as you know what they mean. Okay? Now, what I'd like you to do on your paper is describe to me, before I draw, if I draw another line that's parallel to that, how would I draw it? Is that what you think? Right. Right.
You draw it like right next to it going the same direction.
That same direction?
At the same angle.
Same angle. So basically, what would if you're talking about now, like right, that's not going to be parallel, right? That's not going to be parallel. They got to be going in the exact same direction, same angle. But you know what? Here's what I want you guys to write as far as we're concerned. They have the same slope. How do we describe where lines are going? We describe it by their slope, their rise to their run. So they will have the same slope with the same rate of change. So every single time you see parallel lines, you know they have the same slope. Perpendicular lines are going to be a little bit different. Okay? Perpendicular lines. By the way, what angle does it look like that upside down T form? What angle? A right angle. So even though you don't see it, hey, you don't have to do this, okay? You don't have to write that in your symbol. But that's assumed that that's going to be a right angle. Perpendicular lines have to intersect perfectly at a right angle. Now I'll check just to make sure with my protractor if I actually made that perpendicular. All right, how'd I do? See how it says 90 degrees? All right, so it looks like I did pretty close to being a right angle. So these lines would be considered perpendicular. Okay? So put a little. Now, how do their slopes compare? This is what I want you guys to understand. These slopes are always, there's going to be a new vocabulary, are always what's called negative reciprocals. You're like, what the heck are negative reciprocals? It's called reciprocals. Alright? So they're always going to be what's called negative reciprocals. Alright, so let's give you some examples of some negative reciprocals. Give me a slope. Any slope. Any fraction. 5? Okay.
Oh, you said first.
No, that's okay. Watch. Put 5 over 1. Alright, write that down. Let me tell you what slope is going to be perpendicular to 5 over 1. I said negative reciprocal, right? Mm-hmm. Negative means it's going to be the opposite side. If this is positive, this has to be negative. Reciprocal means the flip. 1 over 5. Those are perpendicular slopes. Okay? Now I'm going to show you this on Desmos right now. I'm going to show you right here on Desmos. So I'm going to write y equals 5x. So there's y equals 5x. Okay? And then down here, I'm going to hit y equals, and what did I say the other slope was going to be? Negative 1/5. Now I'm going to hit the right arrow and hit n x. Now, does everybody see how those two intersect with each other? Can you guys visualize that right angle? Hopefully you can see the. Oh, hold on. Right here, if I rotate it a little bit, you can see that that does form a 90-degree angle right in there. Okay. All right. So let's do another one. Give me another fraction.
4 over 5.
4 over 5. So if I start with a positive 4 over 5, what do you? Okay, go ahead and write negative 5 over 4. Very good. That's how you can tell which ones are perpendicular. All right. Now, another thing about perpendicular slopes, okay? They're products. Their product always equals -1. When you multiply these together, their product will always equal -1. Let's test that with these, right? We have 5 over 1 multiplied -1 over 5, which becomes -5 over 5, which becomes a -1. Over here, if I have 4 over 5 times -5 over 4, their product is -20 over 20, which reduces to a -1. So their products, every single time, when you multiply their two slopes together, what will they always end up equaling? A -1. That's how you can test whether they are perpendicular slopes. If they don't equal a -1, then they're not perpendicular slopes. All right, one more I'm going to give you right here. -1 over 2. What would be the perpendicular slope of a -1 over 2? That's right, positive 2. Now you might say 2 over 1, but what is 2 over 1 simply reduced to? Just a 2. And so when I multiply these together, what is -1/2 times a 2 over 1? That equals -2 over 2, which equals a -1. So I'm going to go ahead and pause the video and let you guys jot these down so you have some examples of what type of slopes, perpendicular slopes in your journal. All right, we're going to go ahead and go to our assignment right here. It says, write the slope-intercept form for an equation of the line that passes through the given point and is parallel to the graph. All right, so we've been given a function right here, y equals x minus 8. What is the slope of this line right here? What's my slope right there? If I interpret that, what's that slope? Because if you look and see, there's a 1 there. Remember, we're doing it in slope-intercept form, which is what? Y equals mx plus b. What's my y-intercept on this line? A -8. We have to find the line that goes through what point? A 5 and a 1. So what slope do we have to have in this line? We have to have the same slope. Because parallel lines, right underneath it, right underneath it, it has the same slope. So we have to have the same slope. So it's going to be a slope of 1. So right here, what I'd like to do on your paper is go up one end, over one, up one end, over one. Follow that pattern. Just follow the pattern on your paper. Plot all of these points right here, and then I would like you to simply draw the line that goes through all of those points. All right. So our equation is going to be y equals 1x, and where did our y-intercept end up happening? Right here. Where's my y-intercept? Right there. At a 0 and a -4. So I'm going to say y equals x minus 4. And that would be the answer for number 1. That's the line that goes through that point right there. Okay. Now, here's what I'd like you to do. I want you guys to follow along and show you how you can use Desmos to help you if you got stuck. All right. So here's what you can do. Go to Desmos. What's your first line that's on the paper? What does it say? Y equals what? X minus 8. Okay. What's the ordered pair that was on the paper, what was the ordered pair that you see on your paper?
5
5 1. So I'm going to type in a 5. I'm going to do a comma and a 1. I messed up. Here we go. 5, comma, 1. What do you notice that Desmos does? It plots that point. Okay? Now, if you understand, you can see the slope of the line, right? So let's say they didn't give you the graph. It was a word problem. You could graph it and see that it has a slope of 1, and you could work your way down, and then you could you could check your answer, which was what? Y equals x minus 4. And does y equals x minus 4 pass through that point of 5, 1? This is a very, very easy way to check your answer. If you did it wrong, if you got this wrong, look, if you said it was minus 5, does that pass through the point? That line does not pass through it. So you have to be able to check your answer. Alright, so we'll do number 2. I want you guys to go ahead, take a few moments, pause the video. I want you guys to go ahead and see if you guys can find the line that goes through that point right there. Alright, this one's a little bit trickier. Alright, so let's look at our very first line right here. What is the slope of this line?
-1.
Very good, -1/2. What does that mean? This is going what? Down 1 and over 2, right? And what's the y-intercept at? -4. Now, interesting. Look right here. That means, we're not counting by 1s, we're counting by 2s. You see how it goes down, -2, -4, so we're counting down by 2s. So let's look at this pattern. It's still doing what? Down 1 and over 2. Down 1 and over 2, but this is actually going down 2 and over 4. Okay? So what I'm going to do, if that point is halfway right there, and I want to go down to that point, I'm going to go over here, and then right there. I'm going to go down right here, and right there. Down 1 over 2. So these are the points that I'm going to be plotting right here. So I want you guys to connect these, and then we're going to use Desmos to check our answer. Y equals mx plus b. What is our slope still going to be? -1/2. What do we have to interpret right now? What the y-intercept is. What does it appear the y-intercept is right there? What would you guys assume that ordered pair is? Right, a 0 and a what? What do you think? If that's at a 2, and that's at a 4, and that's at a 6, and that's at an 8, 2, 4, 6, 8. What number is perfectly between a 2 and a 4?
3.
There you go. Okay? Now, what did I say we were going to do after we do this? We're going to check it with Desmos. Okay? We're going to go over to Desmos. I'm going to write down right here, I'm going to type in a -1 divided by 2 and -4. So there's my line. What was my ordered pair? GMAT, what was my ordered pair for that one? -8, 7. Is that what it was? -8 and a 7, which is right. I don't know if you guys can see it. It's right there. And what did we say our final answer was? -1 divided by 2x, and we said it was at a plus 3. And why is that the right answer? Because it goes through the point -8 and 7. Right? If you would have said it was -1/2 x plus 6, you can see that these lines are parallel, right? They're parallel, but it doesn't go through that. Yeah, and that's what you're trying to figure out. Trying to figure out the line that's parallel that goes through that specific point. That's what you're trying to do. All right. So go ahead and why don't you guys go ahead and try the next one. Right here. We have a point. We have this line. The line is 4x minus 3y equals negative 12. What do I want you guys to be able to do with a standard equation? This is in standard form. What do I want you to be able to do? Be able to interpret the slope, right? So let's change this to slope-intercept. You guys should be able to do this. What is the slope of this?
4.
What do you think it is?
4.
4 over 3, let's check. There's a point right here, right? How much does it go up? 1, 2, 3, 4, over 1, 2, 3. So the slope of this line is 4 over 3. And what's the y-intercept at? Positive 4. Okay. Now, here's what I expect everybody to know how to do. So put this in your journal if you would. We're going to make sure everybody knows how to change things from standard form to slope-intercept form. So write this down real quick. All right, so here we go. First step, to solve, basically what am I asking you to do? I'm asking you to solve for y. To solve for y, what would be your first step to isolate all of these y variables? What would be the very first step to get those by themselves? Minus 4x. We're going to take away 4x from this side. We're going to take away 4x from this side. Okay. We're going to drop down to negative 3y. We're going to say that equals, and all I'm going to do is I'm going to move the negative 4x up front and put the negative 12 in the back. Just move that in the back, move that up front. What's the only other step that we have left to do to get it to y equals? That's right. Divide everything by a negative 3. What happens here? These cancel out. You're left with y. A negative divided by a negative is a positive. And a negative divided by a negative is a positive. So there is your equation in slope-intercept form. Okay. Now, this is the part that's going to be a little bit tricky. What do I have to do with this right here? I have to do the same exact slope. What does my slope have to be to this point, from this point? It has to be a 4 over 3. Right here, I want you guys to go up. 1, 2, 3, 4, and over 1, 2, 3. So we got to do something. We got to do a little bit of estimating. So what did I basically add? I added one line. So this is what I'd like you to do on your paper. You had to go up what? One more unit. This is what I want you guys to be able to do. Use your imagination. Sometimes it may be off of the paper, and you got to use your. So what did I do? I added one more grid. That's what I'd like you to do. By doing that, what does that allow me to be able to do? Draw the line. Okay? And it allows me to be able to figure out what my y-intercept is. What's my y-intercept going to be at now? 1, 2, 3, 4, 5, 6, and 7. So my y-intercept's at a 7. So what would my answer be here? Y equals 4/3 x plus 7. That's your answer. Y equals 4/3 x plus 7. And it passes through negative 3 and a 3. Alright, let's say for example you don't have a graph and you can't clearly see it. Alright, what we're going to do is we're going to show you how to do it by hand, step by step. Alright, we'll do one problem right here. If I need to find the parallel line, I already know my other parallel line will have a slope that is also a 4. All I need to find is my b value. That's all I have to find. Okay. So, in this equation right here, I'm going to show you what I'm going to do. I know my slope's going to be the same, so I already know my new answer will have a slope of 4. All I have to do is take my x value and plug it in for x, and take my y value and plug it in for y. So if I'm not doing it the graphing method, if I'm doing doing it just by hand, the algebraic method, you have to plug in certain numbers in order for them to work. Okay? So right here, what am I going to replace the y value with? I'm going to replace it with a 2. If you're wondering how I got this equation, what form am I using right now? I'm using y equals mx plus b. Parallel lines have the same slope, so that's why I put it in the 4. So we're going to say 2 equals 4, open parentheses. What number am I plugging in for my x value? It's -2. And all I'm doing right now is I'm only doing one thing. I am just trying to find my y-intercept. Okay? So here's what I have left. 2 equals 4 times -2, which is -8, plus my y-intercept, my b value. The last step I have to do is add 8 to this side, add 8 to this side, and I'm left with 10 equals b. Therefore, my final answer is y equals 4x plus 10. And that's it. I'm done. Now, this right here, this line that I started with, this line right here is parallel, and it does pass through -2, 2. And I'm going to show you that it does pass through -2, 2. I'm going to use Desmos to show you that I am indeed correct. So our first line was y equals 4x minus, it was -2. Yep, 4x minus 2. I said my answer was y equals 4x plus 10. And I'm saying that it's going through what ordered pair? -2 and a 2. Okay, now I'm going to close ordered pair. Does my answer go through -2 to 2? It does. So I'm going to do this problem one more time, step by step. I'm going to clear it out. I'll do the problem one more time. So here we go. First thing I'm going to do is I'm going to label my x coordinate and my y coordinate. That's my first step. Second step, I'm using y equals mx plus b. What do we know about all parallel lines? They have the same one.
It's really, really fast.
Okay.
I know I'm speaking for everybody. I know you will look at it.
Okay. One of the reasons why I'm doing a recording is so that you can see things and see it over and over again. So what do I want you guys to understand about parallel lines? They have the same slope. Alright, so the next thing I'm going to do is I'm going to write down, instead of y equals mx plus b, I'm going to transfer the slope that I have. I know I'm going to have the same slope, but y equals 4x plus b. What we're trying to do is we're trying to find the equation that actually goes through that point that's parallel to this line. That's what we're trying to find the equation that goes through that point but has the same slope as this line. So that's where the next thing I did was I know my x coordinate. So I'm going to take the x coordinate, I'm going to plug it in for x. And then I'm going to take the y coordinate, and I'm going to plug it in for y. So that's where I'm color coding. I'm going to go down here. So what value am I going to plug in for my y value? 2. So put 2. You know my slope's the same, so what am I just simply going to drop down? We'll drop down to 4. I'm going to open up a parentheses, and for my x value, I'm going to plug in a -2 plus b. Now we don't know the b value because that's what we're trying to solve. That's the only thing that we don't have in our equation. So I'm just going to write everything in the same color now. So we have 2 equals -8 plus b. Then the last step would be to add an 8 to both sides of the equal sign. You get 10 equals b. That zeroes out, right? That zeroes out, and what we're left with, we're just left with a b. So what does that mean? That means my y-intercept is a 10. Yeah, you're right. My y-intercept is b. Alright, but in this particular case, our b value is a 10. So our answer is y equals 4x plus 10. And that's the equation that goes through negative 2, 2, it's parallel to this. So when I went to Desmos, I typed in my answers, right? Typed in my answers, and this line is parallel to this line, and it does pass through negative 2, 2. Alright, so I'm going to go through this, do this one right here. What's my x value? 6. My y value is 4. Y equals mx plus b. What are we once again searching for? We're searching for a what? Parallel line that goes through what point? That point right there. So tell me something you know for certain about the blue line that I'm going to be finding. What do I know for certain? The same what? So I'm going to put 1/3 x, but what are we going to be solving for? The b value. So write that down. Alright, I'm going to highlight some things. I'm going to highlight the slope as the same color. So those are the same. Alright? I'm going to highlight my x coordinate right here as a 6. I'm going to plug it in right there. I'm going to highlight my y coordinate in red and plug it in right there. Alright. So what number would you think I'm going to plug in for my y value? Equals, put 1/3, stays the same, right? Open up the parentheses, and go ahead, what am I going to plug in for x? 6 plus b. Now what if you didn't know how to multiply 1/3 times a 6? What do you have access to? Calculator, okay? Now 1/3 of 6 is 2, I'm just going to let you know, alright? 6 times 1 is 6, divided by 3 is 2. 2 plus what is 4? 2 plus what is 4? 2. So if you didn't know that, right, you can subtract 2 from both sides, and what do you still get? B equals 2. So what would our final answer be? Y equals
1/3 x plus
2. That's it. That's your equation. That's what? That's parallel. It's parallel to our original line, and it goes through that ordered pair. And if you wanted to, what could you do? Type it into Desmos, see that it does pass through it, and you're good to go. And that's all we're going to be doing.